Good evening, welcome.
Good evening.
एप्लीकेशन सेम है।
Sir, Dr. Vinod, sir?
Yeah,
Dr. Vinod, sir?
Yeah, I am in.
I will start that.
Yeah, my screen is visible now, sir.
I'll just have some brief introduction about this, sir. Then I will switch over to you, sir. That's all. Happy good evening to everyone. Today we have an interesting topic that is power sources for welding. It is a requirement of the day, and it is going to be delivered by an eminent personality and expert, Dr. S. Vinod, Associate Professor and Head of Department of EEE Jerusalem College of Engineering, Chennai. First of all, we thank Dr. S. Vinod, sir, Professor, for accepting our invitation to deliver this interesting topic to our members. We welcome you. We also welcome you, sir, to our IEI Tiruchirappalli Local Center platform, sir. Thank you for accepting our invitation, sir. Today's program is organized by the Institution of Engineers India Tiruchirappalli Local Center in association with the Safety and Quality Forum of IEI New Delhi and Computers of India Trichy chapter, the Indian Institute of Building Tiruchirappalli branch, the Indian Institute of Metal Tiruchirappalli chapter, the Indian Institute of Industrial Engineering Tiruchirappalli chapter, Indian Society of Non-District Testing Tiruchirappalli chapter, Indian Welding Society Southern Zone, and Kumari Arivial Peravai. We IEI Tamil Nadu Tiruchirappalli Local Center conduct weekly Tuesday program for the past 3 decades without interruption. Our aim is to propagate the emerging and latest technology to all our members, student members, faculties, industries, education institutes, experts, and at all to our society in a free mode. Before pandemic, it was in physical mode. It was conducted in physical mode at the Institute of Engineers Tiruchirappalli Local Center, Dr. APJ Abdul Kalam AC Hall, which is situated in our BHL 3,000 acres campus, which was given by the great Kamaraj, our former Chief Minister of Tamil Nadu. And BHL in big way is promoting this professionalism, and there are more than 10 professional institutions housed inside BHL campus, and we are being the role model to conduct regular program, and we are associated with other professional bodies. After the pandemic, we switched over to the virtual mode. Today it is our 164th program. In between then and then we do the hybrid program also. Last month we did some 3 hybrid programs. Our boundaries from Ariyallur, Perambalur, Karur, Pudukottai, and up to Nagapattinam, excepting Tanjore. And we have more than 2,500 corporate members, 7,000 student members. And as a corporate, we have more than 125 centers, more than 2.5 lakhs corporate members are with us, 750,000 student members are there with us. So our aim is, again, I'm telling, to propagate the latest and emerging technologies with experts and all. Now, I call upon Dr. Karpasamy, sir. Are you there? Okay, I call upon Dr. Titus, sir, to introduce the speaker to the audience. Over to Dr. Titus.
Okay, sir. Thank you, sir. Thank
Yes,
you.
sir. Yes, sir.
Very good evening to one and all gathered here, and I'm happy to take this opportunity to welcome the today's speaker on behalf of IEI Tiruchirappalli Local Center. I'm happy to introduce the today's chief guest of head of the department in electrical and electronics engineering from Jerusalem College of Engineering, Chennai. Sir is going to give a presentation on power sources for welding. So I'm happy to introduce and welcome the today's speaker.
Sir, any issue?
Just a minute,
Titus, sir?
Yes, sir.
Yeah.
So can you able to hear, sir?
Yeah. You are audible, sir.
Yes, sir.
Any
Yes,
issue?
yes, sir. Due to network issue, sir, I am continuing, sir. I'm
Okay,
happy to
okay.
welcome the today's speaker, Dr. S. Vinod, who is a professor and head of the department, Department of EEE from Jerusalem College of Engineering, Chennai. Sir has received his BE degree, EEE from SRM Engineering College, Madras, University, Chennai, in the year 2004. And he has done his MEP Powertronics and Drives in Jerusalem College of Engineering, Anna University, Chennai, 2006. And Dr. Vinod sir has done his PhD on power sources for building, and he has 16 years of teaching experience, and he has received appreciation for fostering an ecosystem bridging government, industry, and academia by Texas Instrument from Indian Innovation Challenge Design Contest during the year 2018. He has also received the Best Assistant Professor Award in Engineering and Science from Pearl Foundation Educational Excellence Award to Higher Education in India 2017. He has also received the Best Teacher Award on Bidecennial Year of Jerusalem College of Engineering for the academic year during 2014 and 2015 from Jerusalem College of Engineering. And Dr. Vinod sir has received the commitment to the service on bidecennial year of Jerusalem College of Engineering during the year 2014. And he has also received the Best Paper Award in the IEEE International Conference on Computing, Electronics and Electrical Technologies during the year 2012 for the paper titled on Design of DC to DC Converter for Hybrid Wind Solar Energy Systems, which was cited by more than 30 papers. He has also published 25 papers in the reputed international journals and conferences. He is a senior member in IEEE, in the professional body of IEEE, and also a life member in the Indian Society of Technical Education, IST, and also a member of the Institution of Engineers. And he has published published a book titled on Circuit Theory by Rakshana Publications. I conclude this with a short introduction about our chief guest. I'm happy to welcome for this today's forum on behalf of IEI Tiruchirappalli Local Center. Thank you, sir. Thank you.
Thank you, Dr. Saitas, for a nice introduction of our today's guest. Now over to Dr. S. Vinod, sir, for your presentation, sir. Please, sir.
Yeah, thank you.
Great.
I think now my full screen is visible now, sir.
Visible, sir, but again it is in PPT mode. Is it possible, sir, for you to make it full mode? Previously it was coming.
Yeah, just I have to go out and come back in.
Yeah, okay, no problem. Full screen, it will be visible. It should be convenient, for to receive you. That's what.
Yeah, 1 minute, sir. I will go.
Yeah, we will wait, sir. No problem, sir. Absolutely no. Good evening to everyone. I am Salva R. Salva, past chairman of Institute of Engineering Local Center. I welcome all the dignitaries and all the participants for today's webinar. We are very much happy to welcome all of you.
Now my screen is fully visible, sir.
Yeah, you are visible, but again it's coming. If you problem, please proceed, sir. No problem, sir. Now it's also again it's showing PPT mode only.
Sir, just go to the slide mode, sir. Press F5, sir.
What,
No,
sir?
I have pressed F5, but the issue is sometimes when we are
No,
going
now
with the Google,
previously it was coming actually. Previous presentation it was coming. That's what. Okay, if it's any difficulties, then it's possible make it full, so we can proceed, sir. There's no issue.
just 1 minute, I will
Full
again.
means the clarity will be more this one. Yeah.
Now it is okay, sir? Or again?
Proceed, sir. It's not coming. Anyway, proceed, sir. You go ahead, sir. No problem.
Okay,
You go ahead.
yeah. Thank you, sir. First of all, I like to thank the Institution of Engineering Tiruchirappalli local chapter for giving me this opportunity to present before you. And today, what I am going to take is dealing with power source for welding, which is nothing but power supply for welding machine. Okay. So when you see as a power source for welding, I will go with the conventional welding machine, what is there, and then I will say what is the change which can be done to make it as a fully power electronics based. So this is the diagram of the conventional welding machine where AC supply is first given to a normal diode rectifier, and this normal diode rectifier output will be given to an high frequency inverter. So high frequency inverter will not make
the screen not changing, sir. Sorry to interrupt. Screen is not changing.
I will come back, sir. Is there some issue with the?
Yes, now it is okay.
Now it's okay. But now I am not pressed in control. Is it going to second screen?
No. See,
Again,
actually,
you come back to the first screen.
at the
Now-
top, the slideshow tab you click.
Now it is
Then
okay.
start from the beginning, it comes all right.
Go. Again, go.
Now, once if I press slideshow, then it is not showing the second slide, it seems. Now it is not showing the second slide.
No,
It's
it
only
is
first
first
slide,
one
sir.
only.
It is only first slide. First slide.
Now, whether it is second slide, you can see, sir.
Now it's coming.
Now it is second.
Now it is
coming.
coming.
Shall I proceed with this itself, sir?
Yeah, proceed, sir. Proceed, sir. No problem, sir. Okay, go ahead.
Okay. Sorry for the inconvenience.
No problem. Absolutely no problem, sir. Please go ahead, sir. Please.
Now,
No, its speed is visible. Okay, no problem.
if I increase the zoom size, now at least to some extent,
Yeah. To some extent visible, but okay.
okay, so let us again go back to what is there in conventional welding when compared to fully power electronics based welding machine. In a conventional welding machine, what they do is first they take the AC supply, they will use a diode rectifier to convert it into DC. Then they make it as high frequency AC, just a pulse AC, not a sine AC. They will make AC and
No idea.
so here what we do is then again they will go for a conventional. So there you is my voice is audible?
Yeah, now it is available.
Voice is audible, sir.
So yeah. Thank you. So what will happen is they from AC they convert it into DC, again high frequency AC, again they will step down and again convert it into DC. You have totally 3 stage where they repeatedly go for conversion from one to another, and finally they will get the DC, and low voltage with high current DC is required. So now what I'm going to say is, if I'm going to go with a method where one time I will convert it into, from the single phase AC supply, I will convert it into a single DC source, then with the help of cascaded converter operated in parallel, which means inside this cascaded converter block, there will be 2 converters placed in series. So when you see, there are you can see buck-fed buck configuration, which is from the DC output inside this cascaded converter block, there will be 2 converters connected in series. So thereby you will step down to the required voltage directly without using any high bridge AC inverter followed by your high frequency transformer again converting into DC. All that will be removed. Now what I'm going to discuss is, inside this cascaded converter, I will go for buck-fed buck, then I will go for buck-fed septic, and then I will go for buck-fed chook. 3 different cascaded converter topology I will go and investigate. So first of all, when you put 2 converters, then we should first say what is the importance. Okay, so what motivated me is the issues are when you go with an high frequency transformer, there will be a skin effect, proximity effect, 3-stage conversion process, heat production is more in case, so thereby the performance will get degraded. So solution is a single stage conversion, which means only from one time AC to DC conversion, that's all. Then I will not go for again AC, DC and all. Directly, it is a single stage conversion. So less stress on semiconductor is by I'm going for parallel mode. So current sharing will be there. Thereby stress on the semiconductor will come down and there is no skin or proximity effect. So all this made me to improve efficiency, increase current level, and reconfiguration is available. Reconfiguration is nothing but if there is any fault in any particular switch, since I am going for parallel, if I go for 3 cascaded converter parallel configuration, either one if fails or with the help of other 2, I can even further go with my operation. So that is the main reason going for this. Okay, so going into this, first of all, let us see with what is the 3 different converter topology, and we will select which one is better. Then we will go for controller designing. In controller design, we will go into depth of an hybrid controller. Then even then there is an issue is when you go for power electronics, what Rashid and book says, unless otherwise you go for power electronics, there is no harmonics on EB side. Only if the power electronics come into picture, automatically the power factor and THD will come into picture. So for that we will see what is the solution, like a bridgeless power factor correction and a third harmonic trap filter. Even then I'm able to reduce the THD as well as improve the power factor, but not able to attain the IEEE standard says. So we will go for a PMSG based wind turbine. Where we are closer to seashore or industry located at very outskirts where you will have wind, there we will go for PMSG based wind turbine giving power source for the welding machine. Okay, so let us go with like module 1. So in module 1, we will see with respect to various cascaded converter topology, that is 2 levels step down. First converter will step down to some extent, followed by the second converter. So in this, we should go for what is the need V in after diode rectifier. It will be approximately 230 into √2, that is 326 volts. This 326 volt has to be reduced to 24 volt for your welding. So I give it as a first input to the buck converter. I will try to reduce, then followed by another converter. Either it can be, instead of choke, you can have buck or sepic. All the 3 we will see, and then we will conclude that whether the buck-fed choke performance is better compared to other 2 topologies. So what I have done is by changing in this formula, D is duty cycle divided by 1 minus duty is going to
Sir, Dr. your voice is not audible.
No,
Your
audio.
voice is not like. Yeah.
Yeah, now it's clear, sir.
Now it's clear. Now it's clear.
yes.
Yeah.
Okay, sir. I think some net issue, I think so. No. So
Now it's audible. No problem. Go ahead.
yeah, sir. Now for various buck converter duty cycle, I am for example, keeping the duty cycle of buck converter at 59. What I am trying to see is I will vary the turn on of choke for various value. Let us 45 I will keep, then 40, then 35. The only condition which we should remember is we should not go beyond 50. Then the choke converter will boost. We are entirely operating only in buck mode. That is the input 326 has to be reduced to 24. So that is why the reason I am going with 45, 40, 35, 30, 25. So we can see that for the higher value of duty cycle of the buck converter, I am able to get the required 24 volts. So when I keep my choke converter at 15% T on duty cycle, then with the 47 duty cycle of the buck converter itself, I am able to get 24, which means the possibility of risk reduction has come down. So if any fault on or if sudden increase in voltage on load side due to any variation also, I will have a controllability from my input side. Okay, so this is just a graphical representation. So whenever for this 24 volt, hello, any doubt?
No, sir. Somebody is talking. I ask Selvaraj, please mute. Guys, please mute the people who are interfering. Please go ahead, sir. Please go ahead.
Yeah. Thank you, sir. So when the duty cycle of choke is 45, we are able to see this particular region where the duty cycle is less than 20. But when I am reducing my duty cycle of choke converter, automatically my on x-axis I am able to see at around 50% of the duty cycle of the buck itself, I am able to get the required voltage. So that is what the need for cascading. So that is why we are going for a cascading type of preparing a power source for welding. So first it will be on buck fed buck we will try. Then this is the block diagram of the welding power source with the buck fed buck. This I am calling it as source side converter. SSC is called source side converter, and similarly LSC is called load side converter. So next I will show you how I am going to give the load, which means whenever welding is taking place. So welding, I will start from 0 till 0.1 welding is there. Then from 0.1 to 0.3 there is no welding. Then again from 0.3 I am again welding, which means welding is not a continuous one. It is a discrete. Just when you touch, then current will drawn will be more, and then when you remove it, automatically current will come down. So the break is provided between 0.1 to 0.3. So this is constant till the end of the presentation. So in all the waveform, you will try to see there will be a waveform from 0 to 0.1. Then from 0.1 to 0.3, you will not see anything, which means load is removed. Again, 0.3 load is being added. Okay, so by using a buck fed buck converter, these are the output. Like input voltage was 326 to the load side. But then input for load side was 130. The output voltage for source side converter is 130, and the output for load side is 24, which has been assumed. The maximum power, which is 2.4. Then switching frequency of buck converter I have operated in 25 kilohertz, and the switching frequency of tube converter is 50 kilohertz. And then the input current ripple is the output of buck. When you measure the ripple, it is 1.8, and it is around 10 in case of on load side. This is the drawback when you use buck on the output side also. Similarly, the voltage ripple is around 0.24. So moving into the second type is going for buck fed SEPIC converter. There is no change on SSC side. SSC side remains the same. Only LSC side, which means load side converter. Source side converter will be always only buck, and load side converter we will change it from buck to SEPIC and SEPIC to tube. So when we go for the third one, which is buck fed tube, this is the setup. So similarly, what I have told, source side there won't be any change. Only load side there will be a change. Load side it will be to tube. Now we will see the various performance obtained for the three types of converters. So here I am repeating from 0 to 0.1 load is being applied, and then load is removed between 0.1 to 0.3. Again 0.3 load is applied. We can see the performance of buck fed choke is better, which means current level is high. Then your overshoot is less. Your response is also good. All this thing is done with open loop, not with the closed loop, just open loop for all the three types of converter topology. That is, on the load side, I am using buck. Then on the load side, I am using tube. then on the load side with respect to Chuk converter. So next is voltage waveform. I am zooming this region A alone. See this region A, I'm trying to zooming and I will try to show it just for a clarity. So when you see here, this black line, which is buck-fed Chuk, when compared to other two, this response is little bit better. And similarly, now it is only open loop. It is not closed loop. So you control is not there anything. So whereas when you see on the open loop itself, the Chuk is better than Sepic and buck. So due to this reason, this is zooming at the region B. I will again show. So in this diagram, first of all, we have zoomed here and we have seen what is there. Now I am zooming this particular region B. Okay, so just to see what is the steady state value obtained. So steady state value obtained by Chuk is around 100 amps, whereas in case of buck as well as Sepic, it is less than 90. In around when you see when buck fed, buck is 80, and when you go for Sepic, it is less than 70. Now this is voltage waveform. First of all, what we have seen is a current waveform. Now this is voltage waveform. And again, in this waveform, we will investigate on section A as well as section B. Section A is transient portion and section B at this particular instant. Okay. So when you see compared to other two, Chuk has little bit overshoot, but this is only open loop. So when we go for closed loop, this issue will be taken into consideration. And this is steady state, and steady state clearly says 24 volt is obtained only in case of Chuk, and other two, it has not been reached. So conclusion for three different topology. So buck-fed buck, when you see with respect to rise time, it is 0.03, 0.02 for Sepic, and it is 0.01 for Chuk. Chuk has better rise time compared to other two. Similarly, voltage ripple is 0.75, 1.1 is for Sepic, and it is 0.4 for Chuk. And current ripple also, you can see that for Chuk it is less. Then peak overshoot, and other two, there is no peak overshoot. They are under damped response, whereas Chuk is over damped response. So we will have that 310 is the peak overshoot which is happening place with respect to voltage. Then again, peak overshoot, when you see, usually Chuk converter will have lesser current ripple. That is why even peak overshoot also is less when you see with respect to Chuk with respect to other two converter topology. So summary, what we can say is performance of buck-fed Chuk with respect to rise time steady state condition is better than other two converter topology. So we will let's go with the closed loop operation of buck-fed Chuk converter will be carried out. So in closed loop, we go for PI, then we go for fuzzy tuned PI. Always we are supposed to say only whenever you say fuzzy, it is not pure fuzzy, it is being tuned only from the value of PI. So only I put the word fuzzy tuned PI. Then we will go for hybrid. So in our case, now I will directly step into this. Just for a comparison, I am showing what is obtained from PI and FLC's fuzzy logic controller. The current ripple is 3 in case of PI, in case of fuzzy logic is 5. Voltage ripple is 0.3 and 0.5 for FLC. Then output current rise time is 0.6, whereas FLC is 0.05. From this graph, from this table, it is clear the PI performance at steady state.
No audio, please. No audio, please.
I think network problem, just wait, sir.
I think I have gone out in this particular slide. So shall I continue with the slide?
You can continue, sir. Continue, sir.
Yeah. Thank you. Thank you, sir. So initially, when you start a system, error will be maximum. So in that case, what we have to do is we have to go with fuzzy. Then go on checking with the error. When the error is minimum, kindly move from fuzzy to PI. Then why you will have fast dynamic response as well as minimum steady state error. Minimum steady state error is obtained by PI, and fast dynamic response is obtained by fuzzy. So that is the decision making block. The decision making block will tell about to switch over to which one. Then we will give the gate pulse to the converters. So in that case, what I have told is just shown in flow chart here. So here we can see here starting that hybrid is shown in red color, fuzzy is shown in green color, and PA is shown in blue color. Here I am operating at the fuzzy. So my hybrid is overlapping with the fuzzy. And then when I am identifying that error at a steady state, so my red line, you can see it is leaving the fuzzy and it is catching up with the PI. So which means till this instant, it was fuzzy control. Now it moved to P control just to get the minimum steady state error. I have even zoomed this region where we can see entirely now hybrid is in PI. Initially, it was in, till this instant, it was in fuzzy. Then it moves to PI. So this is the advantage of an hybrid controller. So directly based upon the error in voltage, we will try to jump into PI mode operating or in fuzzy mode operation. So the condition is initially it will be in fuzzy operation, then it will move on to PI. So similarly, this is waveform for voltage, where also I have just shown here yellow circled. I have shown here. Here what we are doing is we are moving from fuzzy to PI. So leaving fuzzy, I am going with PI in this location, and I am able to get maximum output with the minimum steady state error. So just I will show with the tabular column. So when you see here, the hybrid is more or less all the required thing it is there. So initially you can see here, so it is rise time is very high, fast. So in this it is nearly fuzzy. Then under steady state, it is nearly your PI result. Again in steady state current, steady state voltage, and the output current ripple is less in case of hybrid, as well as your voltage ripple is less. Summary. So performance of hybrid controller satisfies the need for welding process by no overshoot problem, fast dynamic response, better steady state value. All is required for a proper welding. So need input AC side investigation. Now, as Rashid Handbook says, Power Electronics by Rashid Handbook says, just by putting a diode rectifier followed by capacitor is more than sufficient to spoil the entire system, because a diode, when from AC put a diode rectifier, then put a capacitor. Usually capacitor is high inrush current, which means they charge at a very faster rate. So current drawn from the input will be like a pulse. Okay, so that is the issue. Just by putting a diode rectifier followed by a capacitor alone. Now, in our case, whenever we move on to power electronics, we have a switching devices. All the switching devices will be operated at very high switching speed. So that leads to further distortion of your input side. So when by using a power electronics based any type of converter or circuit in your experiment or in your work, that leads to drastically disturb the input AC side. So what shall we do is, shall we move on to like something like how to improve the factor and how to reduce the harmonics in the circuit. So I will go for a diode bridge rectifier. Initially, I will say what is the problem, then we will give the solution. Now I am just normally I'm saying that you take AC supply, diode rectified, followed by a capacitor as a filter. Then we will give it to our cascaded parallel buck-fed tube converter topology for welding application. So when you see here, this is what I am showing on input current side. What is the input current drawn from the EB, TNEB? Okay, there we can see the current is like in a spike mode. So just for a small duration of time alone, from the input current is drawn, so which leads to harmonics and reduction in power factor. So we can see the power factor has been brought down till 0.6, and when you see with respect to THD, the THD is around 85.38, which is very little bit very high. Third harmonics is around 73, and your fifth harmonics will be around 35, and seventh harmonics. There is no need to go beyond seventh harmonic. So 3, 5, 7 plays a major role. So now, what is the solution we are giving? The solution is try to remove the capacitor and try to make it as a bridgeless power factor correction with front end buck converter. So what I have done is, instead of putting 4 diodes, converting into DC, then with the help of capacitor to filter, here one buck converter will operate under positive off cycle and another buck converter will operate during negative off cycle and try to get the DC. So correction is made on source side, that is on source side converter. Normal buck converter is replaced by a bridgeless power factor correction buck converter. So this is mode of operation for positive off cycle and this is for negative off cycle. This is our entire setup. With the same setup, I am going for closed loop with hybrid system. So on closed loop is always done on the buck. Our tube converter will be always operated only in open loop. The reason is usually at the time of starting error will be more. Then our rule says you have to give more duty cycle. Then when you bring choke into closed loop, you will go to boost mode rather than buck mode. So that is why choke is not being given with the closed loop operation. Only buck converter is given with closed loop operation. So now when you see the graph, and the current waveform is little bit issue is being solved, not like a drastic pulsating current. So your power factor also moves to around 0.8 or about 0.9, and your THD comes down to 59.9, and it is little bit because of purely third harmonic filter. We can clearly see around 59, 56.3 is from on third harmonic. So next what we will try to do is put a trap filter, but there is an issue. Again, I will say when you put a trap filter, what happens? Your output side power will be less compared to what is the power drawn from the EB, which means efficiency will slightly come down. So when you go for by inserting a third harmonic trap filter, what happens is you can see the current waveform now. Now it is not like as what we have seen in case with respect to without bridgeless and with the bridgeless. So now THD has come down to 13.63. Usually in welding 13.63, because in some other case the load is not such a here load is not continuous, it is discontinuous. That is why we are able to see with respect to more THD. And now somehow we are able to reduce to 6.3 your third harmonic, and total is 13.63, and even now it is not meeting the IEEE standard. So the solution what we will give is rather come out of AC source from EB and go towards a standalone operation. So improvement in power quality, there is some improvement. IEEE standard specification is not reached. Move towards a standalone power source. Here I am showing with respect to, I will show with respect to wind, but you can even go with solar. Okay, so here I am going with the PMSG based DC welding machine. PMSG is nothing but it is not going to be operated at a constant speed. It is wind generated with a variable speed. which is nothing but a rooftop type. So when you go for a factory, I cannot, in front of the factory, we cannot go with the conventional windmill generation, where I can go for rooftop. I will show you there is a rooftop, how we have done the rooftop and all. So rooftop means it will run only at variable speed. So from that you will convert it into DC and then give it to your converter. So this is the block diagram where we can see a PMSG followed by diode rectifier. We will give it to our cascaded buck-fed tube converter for stepping down the voltage and giving it to our required voltage. So in this, we should include an MPPT before giving to our proposed converter. So here it is a SEPIC converter, which is always used as an MPPT converter to get the maximum output from the wind. So the method for MPPT which I have followed is the better one for whenever you go for wind is power signal feedback controller. It is a separate type of MPPT controller, power signal feedback controller, which is nothing but I will get the current value with the help of the graph. Okay, a predefined graph. So this is, we have to simulate it, then we have to do the simulation and we have to get the graph. So that is the PG graph and P mechanical, power generated, power mechanical. There will be always a difference. That means the wind on the blade, all the power will not be converted into your useful power. There will be some loss. So voltage output from SEPIC converter. So for variation in speed, there is variation in voltage, and that is been taken care by the MPPT. So here we can see the MPPT is try to bringing it to maximum. So actual power and output power, that is what been done with the MPPT. Okay, now let us go to hardware. Electrode which we are going to take for welding is E7018. The type of welding rod. I will just show the different types of rods. So rod we usually for mild steel low alloy electrode, we will just say with respect to in size, 2.4 3.2 4 and 4.6 correspondingly. The output voltage and current required for this electrode lies between, voltage is only from 21 to 25, which we say 24, which we try to produce with the help of the cascaded converter. When it is 2.4 size rod, the maximum current drawn will be around 80 amps. Then 3.2 is 110, 4 is around 160, 4.6 is around 210. So with respect to simulation, we have done with all types of rods, and we have seen the graph for rod 2.2, 3.2, 4 and 4.6. All the graphs which I am showing is simulated using MATLAB. Even if you have any simulation issues or any help needed in MATLAB, you can even approach me. Since I have done entire thing in MATLAB, so any suggestions are any required at any time, anybody can call. So this is just a plotting the response for various welding rods. Then summary, PMSG based power source with the fuzzy controller has a fast dynamic response and absence of overshoot problem. So hardware, I will show some hardware so that to some extent it will be more clarity. So this is the hardware setup. We have gone with the PIC16F877A microcontroller, which has a PWM module as well as capture compare PWM is available. So we will using the capture compare PWM mode operation, we will try to capture the voltage and try to make it as digital, and we will try to generate the pulse. So another separate controller is used for MPPT. Then we are using driver IC. 6N136 is the driver IC we are using. This will help in little bit higher frequency, and the output will be more, we say it is pakka when compared to when you go for, there is some more optocouplers and drivers also available, like 3N136 and all. So this is 6N136 we go. And for prototype, we have gone with the Whisper 200 wind turbine, which has been placed. So rotor dia is 9 feet. The weight is around 30 kg. Startup wind is from 3 meters per second. Rated power is 1 kilowatt. So prototype, we are not going beyond 1 kilowatt. So we will try to, the simulation and all has been done for 3 kilowatt, but hardware prototype, we have gone for 1 kilowatt. Okay, so if for 1 kilowatt, this is the wind surveil wind speed is beyond 55 meters per second. It is not allowed. So this is the hardware setup, power from the wind, and the converters is being placed, and then it is being given pulses from the controller, and with the help of fluke meter, we are trying to measure. And this is the rod which you are going to take, which is 1.6 mm, slightly lesser than what I have shown previously. Just to come into the thing is, we will not go beyond 30 amps. So in order to restrict 30 amps, we are going for 1.6 mm rod. Then even if you can go for the 2.4 rod and all. Okay. So this is the hardware output obtained from Fluke, where we can see the voltage is 230 and around 58 on input side, and current drawn on input side is 3.2 amps. So this is with respect to input side current we are showing, that is from our wind. Same, we have done scale down simulation for the requirement. So this is a simulation waveform, and this is the output side on the welding side. The welding current was 30.56 amps, and the voltage was on the welding rod side, it is 24.82. What we required, we have achieved 24. So 24 volts and 30 amps is the load side voltage and current. So simulated also we have seen, again we get the same 24 volts and 30 amps. So this is usually welding will not be a continuous. We have measured for it has been kept, then current reaches to 30 amps. When you remove it, current comes to 0. Again it repeats. So just we are showing about current waveform. So summary is, hardware results validates the importance of PMSG basins. When you go for PMSG, you are coming out of AC side. So when you come out of AC side, automatically you are not disturbing the TNEB anymore. So whatever you generate from wind, you are going to use. Even this can be used with the help of solar also. We have just done with the PMSG. Since it is available in our campus, we did with the PMSG. Even we can go for solar based also. So thank you. I like to say thank you for giving me this opportunity to explain about a power source for welding. Sir, is my voice is it audible?
Yeah, sir. Thank you, sir. Thank you for your excellent presentation on these power sources of welding. Thank you. We are very much happy to listen to you. Now the question platform is open to participants for their questions. If any have doubt, you can ask.
Yeah, even if anyone wants to have any clarification in MATLAB at any point, you can even ask me. I will even give my mobile number, or you can even get a suggestion required, because I have done a huge work on MATLAB.
Sir, how can we measure the arc voltage and arc current? Hello.
Your voice is not audible.
Sir, how can we measure the arc voltage and arc current by the help of CRO, cathode ray disconnect? Chat box question is written in the chat box.
Fluke is the thing we used to use as a measuring device. That able to measure your output values. Fluke is like your CRO. It comes around 3 lakhs. That kit. It will be like a multimeter arrangement. You can see here, no? In my slide, I think you can see a display unit where yellow and black in color. This is with the help of this, we are able to measure the load side values.
Okay, sir. Thank you very much.
Sir, there is a question, some questions in the chat box, sir. I will read out, sir. Please answer. How can we connect a CRO for measuring arc current? Sir, Buddhi has asked, sir.
Yeah, that only I have told no, sir. Now there is arrangement.
Oh, okay. That means okay. Okay.
Yeah.
Then one more question. What is meant by synergic control in welding machine?
Sir?
John Rajakumar asked about what is meant by synergic control in welding machine.
No, I am not clear, sir.
We're not clear.
Sir,
What is meant by
specific type
synergic
of-
control in welding machine? Mr. John Rajakumar?
Can you
Mr. John
unmute,
Rajakumar?
Yes, sir.
Yeah,
Yes.
yeah. Please talk to speaker. Yeah, yeah.
Yes, sir. Very good evening to the speaker, sir.
Yeah, good evening, sir.
Yes, sir. My question is, what is meant by synergic control? Because in the current trend in the welding machine, we are using synergic based controls.
Sir, all that is like commercial terms. Commercially, each and every product manufacturer will specify some specific name to their product. Like when you go for AC, they say inverter AC, like that. They use a particular name, sir. But the controller is, they might have used some special MPPT on to bring back to the required. See, the main thing in welding is not the current, the voltage. Voltage should be always kept it at 24. So that might be, they might calling as like it has a inbuilt property to always bring it to 24, irrespective of any disturbance.
Yes, sir. Because they have even some ready-made programs by selecting one of the.
Yeah, sir. That we can do. Even we have done on simulation with the various rods. I think we have shown the slide where you for various rods. Similarly, in hardware also we have a probe. We have selecting knob. We try to put that knob at various position. Automatically, your duty cycle to the buck converter will vary, and automatically your required thing we can bring it.
That is called, I think, synergic, sir.
Yeah.
Sir, one more question is, what is the difference of single pulsing and double pulsing, sir? Because in double pulsing, the modern trend of welding is under the investigation. So they are claiming, the manufacturer and the supplier of the machine is claiming concurrent pulsing. Any idea about double pulsing, sir?
No, I am not clear, sir. I have no
Okay.
idea.
Okay.
I will check it, and if possible, then I will even.
One more question from the chat box.
Sure.
Sir, one more question, sir. Is there any machine, Mr. Buddhi has asked, is there any machine like portable arc monitoring system? If yes, where to buy? The chat box is there, sir, last. Is there any machine like portable arc monitoring system? If yes, where to buy? Sir, Vinod sir, is it audible? Vinod sir? Dr. Vinod sir? Dr. Vinod? I shall announce the next 6 program. Next 6 program is planned on 7/2/2023. That is going to be delivered by SV Sri Raj, Director EM Corp Solutions from Mogape, Chennai. I request all the participants to spread the information to your friends and also request you to participate. Not only that, we will also send our email and a WhatsApp message to all of you. Thank you. This is about next week's program. Dr. Kevin R. Kumar is there. Dr. Kevin? Dr. Vinod, sir? I think network issue, I think, has not gone out. Now I call upon engineer, I thank all the participants for participating today. I call upon engineer Suresh Kumar, the Honorary Secretary, Indian Soil Building, Tiruchinapalli branch, to propose vote of thanks. Over to Suresh Kumar, sir. Engineer Suresh Kumar.
Good evening to all of you, sir.
Yes, sir.
I would like to express my gratitude to the organizers of the IEI Tiruchinapalli Local Center for the opportunity to me to deliver the vote of thanks. Mr. R. Silvaraj delivered welcome address.
Sorry for the disturbance, sir. I've gone out due to some.
Yes, sir. Vinod, sir. You come out. Don't just wait, sir. Rajesh, Suresh Kumar, wait.
Okay.
Vinod, sir, some more questions are there, sir, the chat box. Is there any machine like portable arc monitoring system? If yes, where to buy? Vinod, sir, are you able to hear? Vinod, sir?
Sir, I am on. Sorry, I'm on due to.
No. Yeah, there is a question, sir. Is there any patient like portable or monitoring system? Mr. Mudi has asked.
Sir, you can monitor with the help of Fluke. Fluke is a manufacturer type of power measurable thing where.
Such as
there are a lot of appreciations for you, sir. That is excellent presentation, sir. Thank you, Mr. Dr. A.M. Sanavas has told. And Dr. C.K.B. Nayak, greetings, excellent presentation, best wishes from Bangalore. And Mr. Manigandan Raj has informative session, sir. These all a lot of appreciations for you, sir. This one.
Yeah, thank you, sir.
Thank you, sir, for the excellent presentation. I will call upon Honorary Secretary, Indian Soil Building, to propose vote of thanks. Just wait, sir. Okay. Over to Dr. Engineer Suresh Kumar, sir, to propose vote of thanks.
Good evening to all of you, sir. Our first and foremost thanksgiving goes to the Almighty God, the creator of you and me, for what we have and what we don't have. Mr. R. Silvaraj delivered the welcome address of today's program. Mr. R. Silvaraj, past chairman of IEI TLC Local Center, coordinating and organizing this webinar. He is a man blended with the industrial experience and a good academic profile. He is organizing the events regularly. Our gratitude to you, sir. Dr. Titus has delivered the introduction of the speaker, of today's speaker. I record our sincere gratitude to you, sir. Dr. of Triple of Engineering is today's speaker. He delivered the presentation about the power sources for welding. He is a person who speaks constructive words and do many wonders. I express our sincere thanks to you, sir, for your support and commitment. Thanks to all.
Thank you, sir.
Thank you, sir.
Sir, Silvaraj, sir.
Sir, your mic is in muted condition, sir. Silvaraj, sir. Sorry to disturb. Your mic is in muted condition.
Sir, unmute, sir.
Thank you, Mr. Suresh Kumar, for an excellent vote of thanks. The vote of thanks. So, I thank you, Dr. Vinod,
Thank you,
for
sir.
the excellent presentation today and also sharing your time with us. Thank you so much, sir. For all the participants, the feedback link is posted on the chat box. Kindly fill it so that you get the e-certificate on your email ID. That's what you are saying. Thank you so much. With all of you, with the permission of all of you, we'll call up the day, sir. Vinod, sir, thank you so much, sir. I thank everyone who participated today. Yes, sir.
Yeah, thank you, sir. Shall I leave?
Yes, sir. Thank you, sir. Good night, sir. Good night, sir. Good night, everyone. Good night.
Thank you, sir.
I request all the participants fill the feedback link so that you'll get the certificate. You'll wait for 10 to 15 minutes. So please fill it all. Yeah. Feedback link is provided at the chat box. Kindly fill it so that you'll get the feedback, G-certificate in your email. That's all. Sir,
Where is the feedback forum, sir?
chat box. It is provided in chat box. Just kindly go through the chat box. Again, I'll put it. That's not. It's not an issue. Now, again, I posted the feedback link, sir. Kindly fill it. Second time I posted. Feedback link is posted on the box, chat box.
By clicking it is not going anywhere, sir.
Hello, sir.
No, clicking on the chat box, it is not taking anywhere.
Yeah, it is going, sir. For me, it's going, sir. For me, it's coming. I'm able to get the link. Maybe is open. Feedback link is open for me. For many people got the certificate also. Many people got the certificate. They are all thanking in the comment, feedback chat box. Just click it or copy and paste it in your Internet Explorer. Then you will get it. For me, it's opening. The form is opening. Many people are thanking for getting the reset in their mailbox system.
Sir, it is not opening. My name is MS Rameshaya, sir. So I have sent the name and email ID in the chat box.
Sir, Mr. MS Ramesaya, are you getting it not? Any issue is there for you?
Now when I click, it is not opening, sir.
If it is not clicking, please copy it and paste it in Internet Explorer. It will be open. For us, it is opening. If it's not opening for you, please copy it and paste it in your Internet Explorer. You get it. You get the form. For us all, many people got the certificate, and also for me, if I click, I am getting the form. There is no issue here.
Sir, it is telling loading, but it is not coming, sir. Rameshaya.
So, Salraj is there. Salraj, Rajesh.
Sir, சொல்லுங்க sir.
Please answer Mr. Ramesh. What is the problem? Please understand.
Okay,
Please
sir.
talk to him and tell the issue.
Okay, sir. Sir, சொல்லுங்க sir.
This that feedback forum I am not getting, sir. So I have sent my name and email ID in the chat box.
Okay.
You can play. They kindly send this certificate.
Oh, feedback you are not getting.
Yeah. It is not loading it.
Okay, sir. I am seeing your chat box mail. Okay.
Thank you, sir. Thank you.
Thank you, sir.
Actually, I am attending from Australia, sir.
No problem, sir. We'll solve it. Participants, we are going to close the program. If nobody has filled in, it's your problem. We are closing the program. Sarvaj, Rajesh, you can close the program. Now already more than 20 minutes gone.
Okay, sir. Okay.
Yeah, please close it. Please close it.
Okay, we can close, sir. Okay, okay, okay.